So this is video 6 in a series of engineering GCSE videos which should help you with your revision. This will continue on from electronic systems, and this is part 3. So the type of content we will be covering in this part is just a bit of a recap over some of the systems that we've talked about and some of the components. So we'll be talking about LEDs, light emitting diodes, 7-segment displays, and we'll also talk about the use of resistors and some of the passive components within a circuit. These questions should get you thinking about the application of what you've learned and hopefully aim to improve your exam technique. So the first question that I'm going to ask you is state the function of a diode in a circuit. The next question will be to give 2 types of resistor that you could commonly use inside a circuit. What I'd like you to do at this point is pause the video, write down your answer, and then once you've answered the question, resume the video to see how close you were to the actual answer. So diodes are components in a circuit that allow the current to flow in one direction only. Diodes have 2 legs called an anode and a cathode. Current flows from the anode to the cathode, and the cathode is usually marked with a silver or black line. Now, in terms of the other question, there are 2 types of resistor that we commonly use. One of these is a fixed resistor, which can have a set value of tolerance. You might set this between 5 and 10%. But there are also variable resistors, which can be adjusted with either a small screwdriver or a small spindle. For example, you might see this on a guitar, a small or a volume control on radios. They are usually found in products where they've got a spindle where you need to adjust the setting regularly. So this is where you might see a variable resistor. The next question in this series of questions, it says, give an example of an output component that produces light. The other one is explain the difference between a polarized and non-polarized capacitor. Pause this video at this point and check your answer to see how close you were There are a number of different components that you can use in a circuit to create light. You may use an LED, a light emitting diode, or you may want to use a lamp as part of your circuit. Some people may argue that a 7-segment display could also be used for producing light, and this was a package of LEDs. So this is actually a group of LEDs created together with 7 segments so that you can produce a full number from 0 to 9. Capacitors are used for storing electrical charge. Their capacitance is measured in farads, and these are used in a very large size and were actually changed so that you could actually reduce the size of these, and they were then called supercapacitors. Polarized will need to be connected in the correct way round, so you'll need to make sure that the positive and negative charge are the right way around, whereas non-polarized can be connected in any way around in the circuit. These are much smaller. The second example in this picture will demonstrate what non-polarized is. So you can see polarized capacitors have the plus to indicate which round they need to be, whereas non-polarized do not. Now these questions have been covered briefly, at least one of these questions have been covered briefly in one of the other videos, and it is, what is the formula for Ohm's law, or Ohm's law? And the other is, state the function of a capacitor in a timing circuit. So again, at this point you want to pause the video, check your answer when you're ready to resume. So if you look on the left here, we have the triangle, which you may remember from some of your lessons, but this is how we work out Ohm's law, or Ohm's law, however you wish to pronounce it. But current multiplied by resistance will give you the voltage. Voltage divided by the resistance will give you the current. Resistance is voltage divided by current. So you can use this triangle to help you in your questions. Now, a capacitor can be used to control the timing of a circuit. For example, if we want a light to stay on after we push a button, we might use a capacitor at this point to provide voltage. And what happens is that voltage is stored for a period of time. So as soon as you push that button, it may be that the voltage is stored for a number of seconds so that the light will stay on for a timed period. And then when that has finished, the light will turn off. And here's an example here below. You can see the capacitor on the left. Our last questions in this video set is, what is the unit of capacitance? The other one is, electronic circuits can be designed and tested using computer-aided design, CAD, before being manufactured. Discuss 3 benefits of using CAD to test circuits before they are manufactured. So to finish off this round of questions, a unit of capacitance is measured in F. We mentioned this in one of the previous slides for this video. And that's to measure the electric charge stored. So if you remember, with the capacitor, it will keep that charge for a small amount of time so that we can use it within circuits. Now, electronic circuits can be designed and tested using CAD. But we need to discuss the benefits of using CAD before the circuits are actually manufactured. So testing circuits is actually cost effective. If you use CAD, you can catch errors much earlier before purchasing components. The great thing about this is it allows you to spot errors in that design process. So if something's gone wrong, we're able to actually stop it before it becomes a bigger issue. It does allow us to save times, because what you can actually do on a computer system is you can simulate what is actually happening, and you can actually run the circuit to see if it works you might be using it on your computer, maybe using any tech software. The good thing about this is it does speed up the design process. CAD software can help us with precise design tools, and the good thing about it is you can actually use CAD software with the manufacturing process, so you can actually use it to see what the product's going to look like beforehand. It does allow for a much higher outcome.